Hey guys, it's me Avidvedi and you are listening me on Extended Reality Developers of India community. And as you know, we invite people from all around the world to discuss about their passion and discoveries in the gaming. And right now, today, Freya is joined with us, and let's talk to her about Neet Corporation. Here she is. Hi Freya, how are you?
Hello, I'm doing great. How are you doing?
I'm good. And
Good.
let's talk about you. I'm following you for quite so long. I have seen almost all your IGDC, Unite, and Glitch talks. So you talk mostly about the maths involved in programming and gaming. So how fascinating it is. It always blows my mind. I also code, so I do understand. And it always blows my mind your work. It's really amazing. So how you started with this?
So I think so let's see. I don't know how far back I should go on this. Um like I think I've always had an interest in geometry when it comes to mathematics. I think mathematics was pretty boring to me for a very long time until I got into geometry and started like applying it practically. I think there's mathematics, when you look at it just as much of numbers, it's kind of daunting. And it's like, oh, what does this mean? What do I use this for? What's the point, right? But
Exactly.
as soon as you look at geometry, suddenly it becomes visual. And I've always been visual minded, and having that connection between the visual and the actual mathematics of something is really valuable because then you don't just memorize the concept, you can actually understand, what the concept is about and how it works. So that was
Wow.
kind of what got me interested in geometry specifically because it was this really tangible way into understanding, math, space, time, all of those things. Doing game development was, yeah, it kind of launched my interest for that very strongly.
Exactly. So let's talk about your company, which is Neet Corporation. And we have
Mhm.
seen a lot of videos from Neet Corporation, a lot of trailers, a lot of amazing tools. And let's talk about the journey, how the Neet Corporation started.
Right. Neat Corporation. Let's see. When did we start it? I don't even remember. I'm bad at keeping track of dates. I guess it's around 4 years ago at this point, maybe five.
Okay.
So it was co-founded in Stockholm
Wow.
by me and Jenny. So we studied together before that at a game development school,
Amazing.
and we kind of wanted to do our own indie games. So
Wow.
we started our studio, and we yeah got started doing that. It was kind of um, like the we're going to talk about it later, but the what made the whole thing possible was that I worked on a plugin for Unity called ShaderForge, and
Wow.
ShaderForge helped us fund the studio because it basically I sold ShaderForge in the Unity Asset Store, and it made literally two full-time salaries. So we had all what we needed to get started working on our own games. So that kind of launched Neat Corporation as a studio,
Amazing.
and yeah, and we were going to work on a different game than what we started working on, but when we were at GDC in San Francisco, we met up with Valve, like completely randomly. We kind of bumped into them at a party, and we got started talking about VR, and they were just launching their Vive at that point. So yeah, we just kind of asked them like, hey, can we get a dev kit? And they were just
Wow.
like, sure. So they were like super casual about it, which was like absolutely wild. We were just this tiny indie studio, and for some reason we got that dev kit, before the Vive was released proper. So that was really, really fascinating to be part of that, the first push for, quote unquote, good VR. So that was really, really fun.
Amazing.
But yeah, so then that's kind of how we started prototyping and how we started, what is fun in VR? We kind of had to answer that question because none of us had that answer because none of us have worked in VR before. And so we just took like 2 weeks of game jamming. We just sat down, experiment with a bunch of things and, try to figure out what is fun, what's not fun, how is VR different, how is VR similar. And there's so much to discover. Like it's very different in many ways, and it's also very limiting in many ways. So you have to sort of um, your games have to be designed with VR in mind. When you make VR games, is something that we quickly realized. Testing different types of games that is fun without VR doesn't always work in VR. So you have to
Wow,
like make sure that your games are properly made for VR. But yeah, so that's kind of what we did at Neat
that's correct.
Corporation at first, which led to the first prototype of Budget Cuts.
Wow. So let's talk about budget cuts. So you showed us the journey that how you started the Neat Corporation, and then you figured out and talked to Vive, and they told you to make this. You came up with the plan of creating the budget cuts. So it's a very interesting story. I recently played budget cuts, and it's really really amazing. It's interesting, and it's very unique in terms of virtual reality locomotions and virtual reality, how you discover the things, the kind of attention it builds towards finding things. So it's amazing. So let's talk about how you decided the story of budget cuts, and what is the plans ahead.
So the story of Budget Cuts or the like more technical bits of the locomotion system?
Yeah, so we can discuss from story, and we can also come to the technical part. We can.
Gotcha. I don't know the story very well of Budget Cuts. I was very much not responsible for that. I was very focused on doing tools and like tech art. So
Wow.
shaders and the locomotion system. I did some of the game design early on as well, but I kind of started doing more and more graphics work at the end of the production. But yeah, I've been super, super focused on the early game design aspects and technical bits. But yeah, the locomotion system was we a lot of us on the team, or actually all of us, were pretty sensitive to motion sickness. And motion sickness it was pretty controversial. I guess it still is to some point, to some degree, because, some people say that you don't get it. Some people say that you get used to it after a while. Some people say that you never get used to it and you always feel sick. And to me, I just felt like these questions are kind of irrelevant. What matters to me is that people get sick now if they play it, and whether or not they can get used to it. Like that's a lot to ask for a player. Like, hey, play our game. You're gonna feel sick for like 5 months until you get used to motion sickness. Like, no, I don't want to do that. That's a great way to make your game feel shitty. So it was really important for us to make sure that you never get motion sick in this game. We didn't want to have that happen ever, which is kind of challenging because we were working on a first-person game and a stealth game at that. And the very early teleportation systems were kind of like you had a stick, you point to a location, you press a button, and you teleport there, and you're there instantly, right? So the problem with that is that there's no time limitation. You go there immediately. And there's no distance limitation. You can point, it's a laser pointer, you can point at a mountain and teleport there. And if you want to limit that distance, it feels kind of artificial. It feels kind of like the game is preventing you from doing the thing you want to do, right? So the the idea that I had was to combine the translocator from the Unreal Tournament series. I don't know if you play those games,
No.
but that translocator and the portal from the game Portal. So it's kind of a combination of those two things where the translocator solves the like distance and time problem. Because in a stealth game, we don't want players to be able to be anywhere at any time. Movement has to be deliberate and kind of slow, right? So the translocator solved that problem because you fire an actual object when you want to teleport to a location. That object flies forward in an arc and then lands somewhere. So that prevents you from firing it, however far you want. And it also has a travel speed, so it has to fly through the air. And rather than having like an artificial timer or a cooldown or a distance limit, we make it into an in-universe feature so that it feels like this is a part of the game. This is how the character moves in the universe, right? So the translocator device is really part of the game. So we kind of started doing that. That was one of the first things we did because having such a like unique thing is really important to like design the rest of the game around because it's very different. Like there are not a whole lot of games that have teleportation as locomotion, right?
Yes.
Yeah, so the idea was that you fired this little beacon that flies out of your gun, and then it lands somewhere, and then it opens up a portal in your hand. And in that portal, you can see where you would end up if you were standing at the destination. And then if you press a button, the portal sort of wraps around your head, and then you're fully enveloped, and then you're standing at the new location.
And
So, yeah.
some of the time, I also noticed the projectile from the gun you shoot, it misses the exact location. So it's a projectile, and sometimes it bounces, it misses the location, and you have to correctly aim it. So that adds up one more level of complexity and one more level of fun for the players. So it was amazing. And let's talk about. Let me tell you a little bit of story of the budget cuts. So the idea is that now humans are not working in the offices, and now the robots are going to take the places. And amount of
Yes.
people who are working in the offices are decreasing day by day, and people are going missing. So you are working as a detective, almost like a detective, and some agency find out that you are the next person who are going to disappear from the office. So you have to save yourself from the robots and all those kind of story. So
Yes, you're
I,
the last human at the office, and they are
you are
about to fire you.
exactly. So it's a very unique, strange, and very kind of matrix kind of story, because this is something which we always think about when we talk about AI and virtual reality.
Yeah.
So this is something not too far from the reality itself. So
Yeah, for sure. I mean,
it's
it's in a lot of conversations now. The for the past like 4 years, like talking about AI and the future of jobs is very relevant and kind of
it's
interesting
very
to like,
relevant.
the
Yes,
philosophy of it is just interesting and weird. So, yeah.
yes,
But
that's
also,
that.
it was also for a different reason that that was actually, we didn't start out with that plan in mind. We kind of started out, sort of a motion system, then the mechanics of, how do we want combat to work? Because, what's fun, what's not fun. Shooting guns turns out not to be very fun. Throwing knives is really fun, so we kind of made that the central gun in the game. But after that, one of the things that decided the story was that killing humanoid creatures that are like actually humans feels really weird in VR. It feels a bit too real in a way, and we were kind of uncomfortable with that. So we kind of like it's a bit of a moral blurry thing where it's you're kind of making a very believable world that's physical around you, and killing something physically by taking a knife and stabbing someone. I don't know. Like, I legitimately don't know. It might be fine. It might not be. But we decided just not to take the risk and kind of go for robots instead. So it's
Yes.
after that decision that we were like, okay, now we can design a story around robots. Like, why are you killing robots? What do they do? Yeah.
So that's an interesting story, and the part two of this particular game is about to come. I have the trailer of that game, the part two, which is about to come. So I would love to represent this trailer. So let's showcase it here.
Well, hello there,
Whoa!
dear viewers, and welcome to the TransCore Daily News. Supervisors are reporting that the incident yesterday at TransCore offices is getting closer to a resolution.
Oh, I can't do this today. I saw it. The ex-employee. It was looking right at me. Red glaring eyes, a mad grin stretched across his puffy human face. Portals opening and closing, knives and arrows flying everywhere. Sending more prosecutors, more hornets, more supervisors, more of everything. This has to end.
Oh, I see. You're an idiot.
Work, digger, hustle.
Whoa! Amazing. So a lot of details. For the first time, we can see the train and these in new environment. But the best part is that the characters are the same old from the first game. So which is a very intelligent thing to do. I loved it. And
Yeah, I mean, there's a lot of stuff that both we and the players really like about the first game, and obviously we want to keep that since it's a sequel and we don't want to make it completely different.
exactly.
So yeah, I mean, like the work bots and stuff, it's really fun to interact with, and all of and the Budget Cuts 2 for us was, it's Budget Cuts 1 was a very big game, but even though it was a big game, there were so many things that we wanted to do that we just never got to do because, we had a very tight development time. We were a tiny team, and we had too many ideas for for the scope of the game. So the sequel made a lot of sense. There was a story we wanted to wrap up. There were so many like level design ideas we wanted to cram into it as well, which is So then that became Budget Cuts 2.
Wow. So let's talk about the other product which your company made. And is this the first product, the Shader Forge? So Shader Forge is a revolutionary tool. Why? Because coding shader is a hard problem. You require a lot of math knowledge, a lot of lighting calculation. It is required to code shaders, but your tool gives some sort of a visual interface to create the shader and edit them. And the best part I loved about Shader Forge was that you can there was no mediatory format. You can simply code directly on shader. You can write shader, and the output is the shader, which can also be used in other applications and any other projects which don't have the shader Forge itself. So it was an amazing tool, and I have personally used that tool, and it's a very handy tool. So what was your experiences about Shader Forge, and how you see it, and when we can expect next update?
I'm not really working actively on ShadeForge. I released an update like 3 weeks ago, but before that, I haven't like worked on it for probably a year or maybe more. So I kind of stopped development of ShaderForge a long time ago after Graph was released. But the update I did like very recently was mostly because a lot of people still use ShaderForge, including myself. And I started developing some of the features in my own local repository. So I thought, why not just release that to the public? But yeah, the ShaderForge is free now and open source, so it's on my GitHub in case people want that. But yeah, there is a node builder where you can make shaders visually instead of having to just write code. And I think
Yes.
a lot of artists are very intimidated by code. Like if somebody is a 3D modeler or a 2D artist, if you show the code, they're gonna be demotivated immediately, even though like shaders are like it's such a visually oriented thing, but when you work with it, you're like writing code. And I think that's a bit of a disconnect, right?
Yes.
You have to be able to visualize code if you want to code shaders, but visualizing code takes like years of practice. So it's having a visual editor makes a lot of sense to me because you're working with something so visual and artistic, right? So it kind of gives, the power to artists to be able to make shaders, because otherwise people are quite limited. Otherwise you're limited to whatever the standard shader is in either Unity or Unreal, and that has a limited amount of inputs. What if I want my detail map to blend between detail maps? Well, you can't do that because the shader doesn't support it. So you need shader. So that was my motivation for starting to write ShaderForge, and also for myself. Like before ShaderForge, I used the Unreal Engine, and the Unreal Engine had a shader editor for a long time, and that was kind of my start with shaders. And then when I got to Unity, I was just like, well, where's my shader editor? I want a shader editor, And so I started looking into how do you make shaders in Unity. Well, it turns out you write code, and I could write code, so I started learning how to write shaders. But after I sort of knew how to write shaders by hand, I felt that it was still a worse way of making shaders. So then I started looking into, what would it take to make a shader editor, right? So I started looking into, what is the scope of shaders in Unity? How do you make editor plugins in Unity? Because I've never done that either. So then I started on this whole journey of writing a very big like plugin for Unity as well as that could generate shaders. Yeah, and it worked. It worked really well. It was really fun to work on it, and I learned so much throughout the whole process because I made so many mistakes in that code. It's full of garbage, but it works, you know.
It works beautifully.
Yeah.
Let me tell you, I have used that and it works beautifully. The only limitation I found was maybe you could have found a way to add the multipass, but apart from that, it was a really
Yes.
awesome tool to work with. So yeah, amazing tool, shader forge,
Consider doing multipass. So,
and it's
sorry,
still
there's a delay. It's difficult. Sorry, I shouldn't interrupt you.
it's still we have now Unity's shader graph. Finally, they came up with a visual tool to create shader, so which is a good thing. And let's talk about the rendering itself. So the rendering is the process of generating images from bunch of line of codes. So how do you see this process, and how do you explain to somebody new who is not familiar with the process of programming or something, maybe a graphic design? How do you explain rendering to people?
So there's a lot of like things involved. I think starting with shaders is probably good place to start. So
Yes.
generally, when you run your game code, it's run on the CPU,
Yes.
which is the little square stuck to your motherboard. Then you also have your GPU, your graphics card, which does graphics, and the graphics card is really good at handling like a lot of pixel. You can like just throw a bunch of data at it, and it can do all of that in parallel. It's so much better than the CPU at doing mass amounts of data that is processed the same way. Um, and shaders are small little code pieces that you run on the GPU. So when you have an object in the world, what a shader does is that it takes the data from the mesh, which is the positions of each vertex, the vertex color, the normal, the tangents, all the data you have in your mesh. It takes all of that, and then it runs something called a vertex shader, which is a little code snippet that has some math where you can define what to do with each vertex. Do we want to add some waves in water? Maybe we want to do that on the GPU. So add some sine waves or some other math in the vertex shader to displace waves in water, right? So that's what you can do in the vertex shader. The vertex shader can then pass data into the fragment shader. So quite often you have UV coordinates. So if you are modeling something, you tend to UV map your objects. Every little point you have in your UV map is a coordinate, a two-dimensional coordinate, right? That says, this coordinate of the texture, I want to go here on the physical 3D mesh, right? Those coordinates are sent from the vertex shader to the fragment shader. And then the fragment shader, instead of being run for every vertex, the fragment shader is run for every pixel that is visible on the screen. So
Yes.
if you write something where I want to make a gradient from left to right on the screen, you can do that in the pixel shader, or you can use the UV coordinates to sample the texture and then display a texture on your mesh. And so that's kind of the core. You have the vertices and all the mesh data passed into the vertex shader. It's data to the fragment shader. The fragment shader spits out a single color, and that is the color of the pixel. So it's kind of like it iterates through every single pixel being rendered. And you can do pretty much anything you want in there, which is really fascinating because there are so many opportunities. So what I'm talking about right now is more similar to like surface shaders, where you have an object that has a physical location in the world that has a surface that is being rendered. But you can also use shaders to do like computing. You can use shaders to do post-processing. If you have bloom effect in a game, or you have motion blur, or you have tone mapping or color grading, all of that stuff is done with a shader, which basically takes all the pixels that are rendered and then do some math on them, right? So that's how you get like all the pretty colors you have in games, right? And all the dynamicness you can have by animating stuff with shaders and mathematics, right?
Yeah, that's awesome thing to have GPUs so that we can solve these problems simultaneously and parallelly on the GPUs. It's amazing to write shaders, and let's talk about the procedural geometry stuff. So I have seen you working on a lot of procedural geometry. You teach people on your streams that how to procedurally generate levels and procedurally generate paths and splines. I have learned procedural geometry myself from your videos. So I have
Oh,
seen
nice.
your Unite talk about procedural mesh generation and spline generation. So that was amazing. You went through each level of detail, and it was really easy to learn. It is a hard topic to learn, but it was really easy to learn. Why I find personally why I find procedural geometry hard, because you can't see any result. Like in shader, you change something and you can see result immediately almost. But in procedural geometry, unless you write 200-300 of code, lines of code, you are not going to see anything appear on the screen. And when it appears, you have to debug hard if it goes wrong somewhere, because the points could be really close together. Naming conventions could be really close. A lot of points, a lot of vertices needs to be assigned in a pattern. So yeah, give us some tips about these procedural geometry. I can talk about this all day, because this is one of my favorite topic too.
Some tips. Visualize stuff immediately. Like you say, it's really difficult to, if you mess up triangle indices, for instance, you get like a nest of just triangle soup, and you're just like, oh, well, what do I do? Or you get like null reference exceptions. So it's very difficult to visualize what has gone wrong in your procedural meshes. So I think a really important thing is to do a step-by-step process of, like, as soon as you generate all the vertex positions, debug that. Like, draw like debug lines or debug points to make sure that do they have the correct order that I wanted to define in this mesh. If I extrude along a Bezier curve, do I do length first in my array, or do I go around the axis first? All of these things, you have to make sure that that's correct. So I think logging all of that is really important. Yeah, otherwise, I don't know if I have any like specific tips other than that, because that's kind of the fundamental aspect of like actually understanding what you're doing. Other than that, it's a lot of like technical stuff. How do triangle indices work? How do vertices work? How do normals work? All of that stuff, right?
Yes, exactly, and that details are really important. So if somebody want to start with that shader coding, your channel is the best place to start with, because you do a lot of these kind of stuff and streams, and I've seen that, and I'm like, I always watch that. There are amazing streams there. And let's talk about the math which you usually showcase in your streams. So this math which we usually use in computer graphics is mostly in various ways, and mostly it is geometry, vectors, and all sort of math. So let's talk about that. What is your experience about that, and how you think it can be simplified, or people who don't know math much, how can they learn it? So what is your opinion?
So that ties into like what got me interested in math to begin with. As soon as things got visual, I was hooked. Then I was like, oh, now I get it. Now I know what trigonometry is. Now I know what it means to do all of these things. I think so. So I think the sorry, I lost my thread. What I was going to say. Right. So when you make games, there are a lot of math functions you use. You don't use everything. You use quite like limited. Vector math is extremely important. That's one of the central things you do. There's a lot of rich mapping. There's some algebra, like not too much. So there are like a few topics that are really important within game development, and I've noticed that there's a lot of people who don't know how these work, and I think that's a massive failure from like the education system to like be able to be inspiring and shit that makes people actually fundamentally understand them, rather than try to memorize some formula, right? And yeah, so I don't know like exactly like one of the problems with like trying to give advice. People often ask me like, oh, do you have any math books to recommend? And my answer is always is like, no, I don't really like. Start making a game. That's usually my advice, and then you start getting into all the things you have to learn in order to make that, right? Because if you just Google for if you Google for the cross product, you go to the Wikipedia page on how the cross product works, you get a massive page with so much information that most of that is absolutely irrelevant. It's like, oh, here's how you do like, I'm thinking 3D game. Thanks, I'm not ready for 7D yet. So I feel like there's a big love in our game developers that we're people who do computer graphics when it comes to mathematics. And so, so I've planned, I haven't fully decided yet, but I'm planning to do, make a book, like an online book about math. And like this bit like geared toward game developers, where the way more visual, because I feel like that's the big problem with math right now. It's very technical. It's very just like focus on the concept, not like exact terminology or any like boring stuff like that, because it doesn't matter. I want to keep it practical. Why is this useful? Why do we use the dot product? Why do we use the cross product? What is it? Rather than here's an equation, it does this with numbers, right? Because it's useless. So I think there's a big gap of a something that is educational about mathematics that is also designed and intuitive and easy to browse through. These two don't really, those two, Venn diagram. So I feel like there's a space for something like this. And like Lucy said, there are like the response I get is like overwhelmingly positive, and like way more than anything else I post. The math stuff is like way more popular, and a very common response is like, why were you not my math teacher when I was in high school? And so I kind of thought, why can I not be? If I make a book, I can teach.
Yes, that is correct, because I have seen a lot of your Twitter feeds as well, and I have showed to the audience as well. So right now in the presentation screen, you can see some of her maths work. So she is right now basically drawing the trajectories, and here we can see a lot of combination of that. So and also there was some circular motions, and this is created from dot products. So also we can see some splines, a lot of math related work you have did on your Twitter. So you create those visual and it's very fantastic. It's very cool to see these visual geometrical problems and seeing them in motion, and it's all constructed using math, so it's amazing to see. So and you also show them on your channel that how to code them, so which is even more fascinating, because seeing this doing this in your head and seeing this visually is a completely different thing. So
yeah, it really is. You have to, like, learning that takes a long time. Like, it took many years for me to like be able to visualize like dot products and cross products in my head.
yes, exactly. And when I started, when I talk about math, I always talk about how we imagine we can basically think about one concept and we can talk about it for hours. Even we saw that particular geometries in our dreams and all stuff like that, because it's very visual, and it's the way the world looks, and describing the how the world looks is through math. So math is the language of the universe, and it's amazing to see it visually. And I would definitely recommend people visiting your channel and learning from you, that because the kind of math you show on your channel, it's amazing, it's fascinating, and geometrical problems are really visual there. So let's
Thank you so much.
yeah, it's amazing. And you are also coming up with one more game recently, Garden of Sea. So I have the trailer. If I could play that, and if you can tell us something about that game, because it's
Yeah, sure.
really really interesting to see. So again, it's from Neet Corporations, your company, and yeah, here is the trailer. So it's related to birds, and it's a VR game too. Wow. So we can definitely see some farms. We can see chickens, some birds. So what is this game and what is it all about?
The kind of the core of Garden of the Sea is it's a gardening game. It's sort of like one of those management games where you have similar to like Stardew Valley, for instance, where
Yes.
you're taking care of your farm and you're kind of building your little home basically. And it's kind of the polar opposite of Budget Cuts, which is very like stealth action and stuff. Whereas Garden of the Sea, where we want to make that a very like relaxing experience and kind of just tending to your stuff and creating things at your own pace. Then we also have a lot of creatures that we want to have in the game that you can sort of connect to and interact with, and yeah, so we're gonna have it's the point is that it's supposed to be a very cute and soft and good world. Yeah.
Amazing. It's a fantastic to see, and the art style is really unique. In virtual reality, I have rarely seen this art style, this cartoonish art style, because virtual reality, whenever you go in there, you feel the experiences. It's not a video; it's a experience feed. So seeing such kind of unique art styles in such virtual reality, it's amazing. I would love to experience them once. So let's talk about some tips for maths. So if somebody want to learn maths, so what are your quick 5 tips for them?
Oh geez, so I need exactly 5. Okay. First one. First one depends on why you want to learn math. So most people who come up to me who want to learn math want to learn it because they want to make games. So my first tip is don't learn math, start making a game that requires you to learn math. There's like a subtle difference there, because if you start making a game and then you start realizing, oh, I need math here to solve this problem, what is the angle between these two things? Then you can start finding the math that is relevant to you, and then you can see, how does this solve the problem that I have? I mean, it's basically learning by doing. You're finding the reason for it first, and then you learn the math.
Exactly.
So that's kind of my first tip, I would say. That's my general tip for learning anything. If you want to learn game development, make games. Don't
Make
read about
games,
making
yes.
games. Make games. right?
Otherwise, you're gonna spend all the time studying, and study is never going to end, no matter how great you become. That's
Yeah,
true.
and then obviously it's different if you have a math test and you need to study for that, then obviously you need to study for the things you're going to be tested by, right?
Yes.
My second tip would be to visualize it. I think visualization is crucially important. If you are making some math and you don't really quite get how it works, start visualizing it somehow. If you can code, draw some lines, draw some points, and try to explore what it actually does. Look at the numbers. How does it change when I change the input values? Like kind of explore what it actually physically does to all the things that are in it, especially if it's like geometric or it's a position or a direction or a vector or whatever. Then I think visualizing is super, super important. So I guess that would be my second tip. Third tip. Let's see. I'm getting nervous. How am I going to think of 5 tips? One of them that I think is pretty important is to have fun. I don't know, maybe it's not for everyone, but I think it's fun to play around with math. It's kind of like something is happening to a system, and what system? If I change this number to something absurd, what happens to the values? What happens if I divide by 0? Well, what happens to when something approaches 0? It can inform you about what it does and how it works when you play around with it. And something that I do as well is that I make art with math. Because I'm an artist and I enjoy doing art. So, taking math and making art with it makes sense for me because I enjoy both of these things. So, yeah, so I think that's playing around with it and making it fun instead of just being daunting numbers you have to learn is really important. But then again, I'm interested in math, so it's easy for me, but it might be more difficult for someone else.
I have recently
yeah.
seen a tweet of yours where you mentioned that pi is overrated and tau should be used much more. So what is that
Yes.
about?
Oh gosh. How deeply should I go into this? Okay, so pi is a constant that a lot of people are familiar with, right? It's the
Yes.
circle constant.
Yes.
So pi it's a ratio between the circumference of a circle and the diameter of a circle.
Yes.
So that number is a ratio between, how many diameters do we fit around a circle, and that turns out to be 3.141, etc. So that's all well. Great, nice. We have a circle constant. Turns out the circle constant is super useful in math. We use it everywhere. But there is also an angle system that we use. So quite often we measure things in degrees, right? So we have a full circle. Quarter turn is 90 degrees. Then have 180 degrees for turning completely opposite. And 360 degrees is a full turn, right?
Yes.
So that's a way of measuring angles. So then we can use that, and that's all fine. And then people discovered that if you use a different number for the angles, you can have a lot of interesting relationships between, like, the radius of the circle and the arc length of the angle. So we invented a new type of angle that we call radians. And one radian is the angle that is covered if you take the radius and kind of squish it up along the edge or along the edge of the circle. So that is 1 radian.
Yes.
So now we have a new angle where this is a 1. So then you might ask, what is the full turn of a circle? So we repeat that one around the circle. So that is like 6.2 something, which is exactly 2 pi.
Yes.
So it's pi multiplied by 2 is a full turn in radians. And that is extremely confusing. So if you want to work out, what is a quarter turn of a circle measured in radians, it's like, let's see, so a full turn is 2 pi, half a turn is pi, so a quarter turn is pi divided by 2, which feels weird. Like, why is not a full turn pi? Like, why is that not the case? So there is a different way of doing this. We have 2 paths, basically, forward to solve this problem. One way of solving it is to use a different circle constant. Instead of using pi, we can use a constant called tau, which is exactly equal to 2 pi. So then what that means is that a full turn in radians is tau instead of 2 pi, right?
Yes.
So if we want to get a quarter turn, then that's tau divided by 4. If we want to get a half a turn, that's tau divided by 2, right? And that makes so much more sense, right? And what that leads to is that in so many equations out there, it says 2 pi, 2 pi, 2 pi, 2 pi, 2 pi everywhere, and like so many equations that has to do with angles. It's just like, why can't we just use tau, right? It makes everything so much better. And the other option we have is to redefine radians, the angle unit of radians. Instead of radians being the radius squished up, we can redefine it to be diameter squished up, right?
Yes.
So then a full turn would be pi. But we haven't done that either. So now we have this shitty system where pi is defined by the diameter and radians are defined by the radius. But they should be the same. We should use the same for both of them, right? We live in this like weird universe where we didn't go either way. We kind of went for the worst middle road where we just took half of one world and half of another world. So now measuring angles is garbage. So yeah, that's what frustrates me about that. So my 4th tip: use tau. Tau is great. So yeah.
Exactly, use tau. And it solves exactly a lot of problems and reduces a lot of complexity. So for visualization, tau is really amazing. I have saw this as well. So let me conclude this with one more topic. Why I love learning math, doing the way as you suggested. Just keep doing the task and figure out how to solve them using your math. So this is the perfect way you suggested, and this was your first suggestion, and it's amazing. Why? Because when you learn just one topic to learn, when you learn just one thing to do, for example, when you learn how to measure angles, you solve a ton of problems with that which are going to be similar in nature, and you are going to solve them by just learning one trick in math. So there are a lot of tricks which are going to solve a lot of problems, and you don't have to be a mathematical genius to solve the game programming or the programming or anything. for example, even in the neural networks, we code a lot of math, and there's a lot of calculus, but I hardly use any sine, cosine in neural net programming, because the derivatives between the bitwise operations is very different from the things we used to do in the math books. So it's very, very different concept. And
Sine and
now,
cosine are used a lot in game development, though.
exactly, that's true. And now let's talk about Freya's advice for people who would like to be exactly like you. So people who love to do
What am
graphic
I?
programming. Yeah.
So if you want to learn, like I mentioned before, if you want to learn how to make games, make games. I'm so it's so disappointing quite often to me, like the resources you find online if you're if you want to learn how to do math or make games. If you find a game design book, you can read the entire game design book and you're not going to make a game at the end of it. I think quite a core feature of quite a central thing in learning how to do something is to start doing it. And that means that you're going to fail. You're going to fail a lot. You're going to stumble forward and you're going to, find all the gaps in your knowledge. But the point of doing that is that if you do the thing you want to do, then you're going to learn the things you have to learn to make that thing, instead of learning everything there is to know that you might need in all the games, right? Because that's the equivalent of you want to learn vector math, so you learn all of math. You don't do that. That's just not a good way of learning, right? So for me, I always recommend be laser focused on the thing you want to learn. Otherwise, you might risk feeling overwhelmed because there's so much math out there. I mean, even like I mentioned, even if you just want to learn the cross product, if you search for cross product on Wikipedia, that is overwhelming, right? So it's just So I think trying to laser focus on exactly the thing you want to learn is really, really, really important. So I think. I think that would be a good start. There's obviously some studying you're going to have to do to get started. Even getting started is difficult sometimes. If you don't know how to code at all, there's some groundwork you have to do in order to get started with coding. But other than that, I think getting started as soon as possible, as soon as you have some sort of interaction, something happening where you can experiment with code, then you can get started making a game. And kind of always setting up a goal that is slightly outside of what you're able to do. When I set up the goal to make ShaderForge, I didn't know how to code shaders. I didn't know how to make editor scripts, but ShaderForge forced me to learn it because I had to learn it to make it, right? And also, I wanted ShaderForge. I needed ShaderForge for my own work. So, I was motivated to do it. And that motivation goes so far. If you have motivation, if you have ambition, you can channel that into learning really, really well. But if you're not motivated, but you're covering a big area of, mathematics or whatever you're learning, then you're going to get demotivated. And in the end, even though you planned to learn more, you're going to learn less in the end because you're not going to be motivated. So channel your motivation, because that's one of the most powerful psychological forces you can work with. Because brains are difficult. You can't just decide to learn everything and learn everything. You have to cater to your shitty brain that's always I want to do this, which is basically me. I just want to do a certain thing, and then I have to okay, sure, let's just do the thing, and then try to guide that into something that will teach you the thing that you want to learn.
Amazing. So before we wrap up the show, we have a last segment of the show, which is Avi's challenge. So I challenge people with the Bollywood dialogue, and they have
I'm nervous.
Exactly, I'm just making you nervous. So don't worry about it. It's very simple. So Bollywood. If you have you ever heard of Shah Rukh Khan?
I recognize it. Yeah.
Yeah. So Shah Rukh Khan is one of the most popular actors from India, and he has a iconic film called Om Shanti Om. So it's a dialogue from that movie, and the dialogue is "Picture abhi baki hai mere dost." So picture means photograph, picture. Abhi baki hai mere dost. So.
Geez. I need to write this. Okay, can you say it again?
Okay, picture abhi baki hai mere dost. Let me type it for you. Okay, so yes,
No, I got it. I wrote it down. I think. Okay, say it one more time.
Picture अभी बाकी है मेरे दोस्त.
Okay. Oh, geez. Okay, what does it mean in the first place? I don't want to say something bad.
Okay, so it means that if it's a bad ending, it's not yet end. The good things has to be happen, and the good things has to come in your way. The
Okay.
exact
All right.
meaning of it is the movie is still left. Picture abhi baki hai.
Wait, but also the last part, right?
Yes,
Meri dost?
mere dost, my friend.
Okay. Picture abhi baki hai meri dost.
Yes, exactly. One more
I
time.
tried.
Picture abhi baki hai mere dost.
Abhi baki hai meri dost.
Exactly. So now you know at least much more Hindi than Namaste and Shukriya.
Great, I know Hindi now. Thanks.
Yes. So you came to IGDC, and how was the experience?
It was super interesting. Like I'd never been in India before, and it's very different.
Wow, it was your first
And
time?
like
Yes.
yes, my first time in India. I've been in Asia before, but then was in Japan, which is very different as well. So yeah, it's like I've been to a lot of like game dev stuff, in Europe, which is different from the game dev stuff in the US, which is also different from the stuff in India. I noticed. So it's really interesting to see like both the differences and the similarities between these groups, right? To some extent, it feels very different. In Europe, you have a lot of like indie developers who are kind of reserved and like are shy, and everything feels kind of stale and awkward, but everybody's like super good. And then I'm stereotyping hardcore right now, but then in the US, you have a lot of like very feels like fake extrovert people trying to sell you things at all times, because there's a lot of like business people and whatnot. It's kind of weird. There are of course like all sorts of types everywhere. Yeah, and then you have India as well, which was very mixed. Like there was a lot of like mobile developers. There was a lot of there was like this aisle of indie developers, which was really nice to see. And the indie developers are a bit more my crowd. But yeah, it was just interesting to see like how these things are different between different places, and also how people are so similar, right? Like as soon as I start talking about shader coding with someone, like after my talk, I talked to a bunch of people, and it just seemed like as soon as they start talking about game development or shader coding, it's like we were like from the same place. So like we speak the same language at that point, right?
Yes, a lot of people talk to me about your talk. You explained the lerp motions and all, and they loved it, and they said it's for the first time they seen the visually how the lerp works, and they use it all the time. They use it all their day in some form or the other. The lerp is linear interpolation. So, and you described it in such a way that everybody was very happy about it, and everybody was talking to me about that how good it was. I missed it this year, but I'll come to IGDC or maybe in your country next year. So it's amazing to have you on the show. Thanks for giving me your time and giving us your knowledge about
Again, thanks for hosting me.
Yes. So hi guys, this was Freya, and Freya today joined us on the Mathology. So Mathology means we talked about the math involved in games, and we talked about the indie game development. We talked about her projects, in which include the Budget Cuts, which is an amazing game, and the second version of that is about to come, the second sequel of that. And also we talked about her programming with the shaders and Shader Forge, which was a tool much before Shader Graph from Unity, and it was for Unity because there was no visual shader editor, and it is really a necessary. It was an amazing tool to have. So you can join Freya's YouTube, and you can follow her work on her website as well, which is neetcorporation.com. So I'll post the links in the post, and that's it for now, and have a great day guys.